Good day. Welcome to Chapter 2, Lecture 3. In this lecture, we will be focusing on Objective 3. Objective 3. Estimate a variable and fixed cost equation and predict future costs. We may state the total cost equation as follows. Y is equal to A plus BX. In this equation, Y is total cost, A is total fixed cost, and B times X is total variable cost. B is the variable cost per unit, and X is the number of units. Let us consider this example. If fixed costs are 125,000 Rand and the variable cost is 70 Rand per unit, what are total costs for different levels of production? So in this example, we have fixed costs of 125,000 Rand, and we know that the variable cost per unit is 70 Rand. So we will have only to substitute the number of units into X in order to calculate total cost. And given each level of activity, then the total cost is indicated in the last column. Estimating fixed and variable components of mixed costs. If we have a total cost number, how do we break that total cost number down into fixed cost and variable cost? There are three approaches that can be used: the scatter graph approach, the high-low method approach, and the least squares regression approach. The scatter graph approach, a line is fitted through cost and activity data points. So in effect, what we do is we plot observations on a graph, and then we draw a line through the observations, and the point of intersection of the fitted line to the y-axis determines the fixed cost component. With the high-low method, we calculate the variable cost per unit by using a certain formula, which we will look at just now. And least squares regression is a statistical analysis method that calculates the fixed and variable components more precisely than the high-low or the scatter graph method. Let us look at this example. What we have over here is information relating to an airline, the flight hours, which is in effect X in the formula Y equal to A plus BX, because flight hours represents number of units and maintenance cost is the total cost. So we want to now use the scatter graph approach to break this maintenance cost down into the fixed and variable cost. So we will plot the activity level and the maintenance costs on a graph. So on the vertical axis, we measure maintenance costs, and on the horizontal axis, we measure flight hours, and we plot each observation. At 21,000 hours, the maintenance cost is 84,000 Rand. So at 21,000 hours, maintenance cost 84,000 Rand. So once we've plotted all our points, there are 1, 2, 3, 4, 5, 6 observations. 1, 2, 3, 4, 5, 6 observations. We then draw a line of best fit through these observations. The line is positioned such that the distance of the actual observations from the line is minimized. So that's why it's called a line of best fit. Once we've plotted the line of best fit, we can extend it down to the vertical axis, and the point of intersection of that line what the vertical axis represents the total fixed cost. So in this case here, if we were to extend this line, it would probably give us an answer of maybe $45,000, just looking at it visually, just a rough estimate. So that would then be the total fixed cost, because on this axis quantity is 0, and the total cost when your quantity is 0 has to be the fixed cost. And once we've calculated that fixed cost, the difference between the total cost and the fixed cost will be the total variable cost. We have the same data now, except that we want to use the high-low method to determine the fixed and variable components of a mixed cost. So with the high-low method, we use this formula that variable cost per unit is equal to change in total cost divided by change in activity. And how do we measure the change? Firstly, in the numerator, the change in total cost is the cost at the highest level of activity minus the cost at the lowest level of activity, and the change in activity is measured as the highest activity level minus the lowest activity level. So we must go back to our data and identify the highest activity level, 23,000, and the lowest activity level is 10,000. So those two observations are critical to us. So 23,000 and 10,000, and the accompanying total cost is 90,000 and 64,500. So the highest level of activity, the lowest level of activity, and the accompanying costs, we then apply that into our formula. The cost at the highest level minus the cost at the lowest level divided by the difference in the activity between the highest and the lowest gives us a variable cost per unit of 1.96 per flight hour. We then take any one of these two data points that we've selected as the highest and the lowest, and we can calculate the fixed cost as being equal to the total cost minus the variable cost. So if we were to take the highest level of activity, 23,000 flight hours, times the variable cost per unit, that would give us the total variable cost, and the total cost minus the total variable cost is equal to the fixed cost. So we can now calculate the total cost equation as y is equal to a, total fixed cost, plus b, variable cost, times x, the number of units. That brings us to the end of Chapter 2, Lecture 3. Thank you.